Welcome back, folks. So I have this stupid little Hyelec power supply, again, the PS28A, the one that created more noise than it actually had voltage coming out of it. And I'll leave a link to that video up there. So I've got it all apart here. Now, what I'm going to do is I'm going to have a look at trying to improve it. I'm doing a little bit of research on switch mode power supplies. Sometimes, what happens is they'll drive the gate of the MOSFET too hard, and that creates all sorts of switching noises or very, very high frequency components in the switching noise that are not properly filtered coming out of the system. And when I looked up this MOSFET and I looked up this PWM driver here, there's a little 8-pin chip here. Indeed, it's coming straight out of there going into the gate, and this has got a totem pole output, a couple of fairly high current MOSFETs to pull up and pull down the gate. So what I'm going to try to do is I'm just going to try and slow the rise time of the input to the gate a little bit. I'm just going to put on there a 7.5 ohm resistor. So what I'm going to do, and I can reverse this very easily, I'm just going to cut this trace here, and I'll put on the resistor just between this via and the gate pin there. Let me do that. We'll come back and then we'll hook everything up and we'll see what kind of noise we get out of it then. Okay, I got that resistor soldered up there, and it measures between pin 8 here and the gate measures 7.6 ohms. Let's try that out. Now I'm going to get it all hooked up here, and we'll put a load on it and we'll have a look at the noise to see if it's better than what we had before. Okay, I'm using these two 10 ohm resistors here in parallel to give us 5 ohms, and that should give us about 2 amps up around about 10 volts. So let's turn the voltage down on this and turn it on, keeping my hands away from here because it's about 150 volts at that point. Just get the scope up there, and we can see that just right down here, 30 milliamps at 1.5 volts. We've got about 440 millivolts peak to peak. I'm going to turn this off, let the voltage die down, and see how much of that is ambient. So let me turn off some stuff around here. It looks like a good deal of it is ambient. So we got about 80 millivolts of ambient noise. And turn this back on again. I mean, these wires are acting like big antennas. We'll worry about all of that if we ever get this even close to being good. So here we still got about 440 millivolts with practically no load on it. Let's bring up the voltage a little bit. So we bring up to about an amp of load. Let me see if I can get that trigger to work a little bit better there. The nature of the noise is like, there we go. Oh, again, the peaks are going up around about 1.2 volts. So we haven't improved anything by putting that resistor in. We got it up. Yeah, we're really getting the good stuff here, right? We got about 10 volts there, about 1.9 amps, and we're pushing peaks out on the noise of up to 4.5 volts there. So that didn't help much. I guess the next thing I can try is a filter. So I could try putting an EMI filter like this on it, but this is not going to fit in the case, so this one here wouldn't work. But we could just experiment around with it and have a look at that. So yeah, that resistor hasn't helped at all. I think it's just a bad design. I mean, it looks like it's got all the right components. The MOSFET and that MOSFET driver, the PWM driver, are good components. They're from good manufacturers unless they used fake components in it. Who knows? But yeah, it's still as ridiculous as you can get. All right, let's try putting that EMI filter on it and see how that works. Okay, we got this egregious little thing back together again. So let's just take stock of the situation. Let's turn it on here. Down to about 3.4 volts peak to peak noise over an ambient of about 80 millivolts, 40 millivolts, somewhere around there. Okay, so what I'm going to do now is I'm just going to hook this up to it and hook this up to the load and probe that and see what that looks like. see if we can get this. I'd like to in order to make this power supply useful at all, we need to get that down, like, let's say under 100 millivolts or two, peak to peak. I'd be even happy with 500 millivolts peak to peak, because the RMS value then would be practically nothing, considering the kind of waveform it is. And I can show you that. Let's get it singing here, and we'll stretch out that. So that's basically it. You get a burst like this when it switches, and they're few and far between. So the RMS voltage is actually be quite low. But let's not concern ourselves with that right now until we make some sense out of this. All right, let me set this thing up to run this EMI filter on it, and we'll come right back. All right, so this is the way we have it hooked up. We still got the same 5 ohm load on it, and I've just used some copper wire to go into the EMI filter here from the power supply. Then I have the scope probe attached via these little pigtails here, directly to the output of the EMI filter where the load is. And it looks like we're dealing now with considerably less ambient noise. It looks like we're at 14 millivolts. Let's turn it on and see what we're getting. I think we're up close to 2 amps already. No, we're at 1.5 volts, 0.29 amps, and we're down under 60 millivolts. It's bouncing around a little bit there, but I think the highest I see is about 56 coming up. And when we turn that off, let's turn it up to half an amp. Got a half an amp there. Now we're up to 50, getting up to 60 millivolts on the peaks. Let's bring her up to 1 amp. 0.98. 60, 70 millivolts. And let's go all the way up to 2 amps, see what we get. Okay, 2.05 amps, and oh, that's very good. So it looks like we're getting some peaks up around about 190 millivolts, but I consider that to be usable. Let's see what that looks like. Let's add in here RMS, and we'll see what that looks like. Well, 25 millivolts RMS. I'd say that's pretty acceptable. That's pretty good. So how do we get this huge big filter into this case? Well, it's impossible. I've got an idea. There's a smaller filter that I might be able to squeeze in here somehow. I'll show you that in a second. But I think we've made some progress that we can actually get a pretty useful power supply out of this. So yeah, we're getting up to around about 200 millivolts there from time to time on the peak to peak. I'd say that's pretty acceptable for a really cheap switching power supply. Now let me just show you the filter that I'm going to try and put in it. I'm going to put that in, and I'm going to change this power cord to a grounded power cord so I can bring those wide capacitors down to ground. That should help out a little bit too with the leakage voltage from this thing. Okay, here's a look at the filter that I've ordered in for the Hyelec power supply. You can see here it's not as many stages as the other filter, but we'll see how it does. We'll get it in and we'll try to find a place to install it in the box there. And like I said, we're going to bring in a 3-wire power cable so that we can hook up that ground on the line side, which also seems to go to these capacitors over here. The little ones there, those Y capacitors at the load side of things. And that should help with any leakage voltage. Not that I think this power supply has much, but yeah, when this comes in, before we install this, we'll do a leakage voltage test on it to see how much it is, and then we'll look at it afterwards. But anyway, that's it. That's the plans. If this works almost as well as that other filter that we tried out today, it should at least make the power supply usable. Getting a peak-to-peak voltage from 3 to 4 volts all the way down to a couple hundred millivolts will be fine. That'll only be at the highest current output of the supply, so for most things it should be just fine. But it is a shame that they didn't design in proper filtering in it in the first place. So this does add $7.87 Canadian to the price of the power supply, plus all the time I've had to put in to try and fix it. These companies really would be more successful, I think, honestly, if they just built better stuff and charged maybe a few extra dollars for it. But then again, people do tend to go out and buy the cheapest possible thing, don't they? All right, folks, thanks for joining me today. I really appreciate it. And we'll see you in the next one. Bye.